Hi everyone, I hope you're okay, and I hope that the videos will keep uploading and helping you out. This is the second video, guys, where I'm tackling an electrostatics question. Please note that, guys, there will be a total number of 13 questions that will be answered, and all of them are extracted from past exam question papers. So it's very important for you guys to know how to answer exam-like questions. It will give you an edge whenever you are writing your exam. So please do share to your peers, whether you're doing grade 11 or grade 12, it doesn't matter. When it comes to electrostatics, you guys are writing one and the same thing. Okay, we are told that two identical spherical balls, P and Q, each of mass 100 grams, are suspended on the same point from the ceiling by means of identical light inextensible insulating string. Each ball carries a charge of 250 nanocoulombs, positive 250 nanocoulombs rather. The balls comes to rest at the position shown in the diagram below. Okay, so the charge over here is positive 250 nanocoulombs, that's 10 to the negative 9. Positive 250 times 10 to the negative 9 coulombs. Now, we are told that in the diagram, the angles between each string and the vertical are the same. Give the reason. It's because firstly, the charges are identical, they have the same mass, and the electrostatic force between them is also the same. Are you together? The electrostatic force between them is also the same. So you can say that both these charges are at equilibrium. They respect Newton's first law. Okay, 7.2 must state Coulomb's law in words. It simply states that the electrostatic field, the electrostatic force between 2-point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance apart. Okay, and then now we are told that the free body diagram, which is not drawn to scale, of the forces acting on ball P is shown below. Okay, that's true. Now they want us to find the magnitude of the tension. Please note that, guys, since we have our tension applied at an angle rather, we can have the vertical component and the horizontal component of our force. For sphere P, if this is our tension, right, we'll obviously have a horizontal component as well as a vertical. Let me draw the horizontal component in a different color. We'll have a horizontal component as well as a vertical component, right? If my angle is right here, that's 20. Remember that, guys, that's my tension. This is my horizontal component, Tx, vertical component, Ty. I want to find the horizontal component. Are you together? My horizontal component is opposite to the given angle over there. And there's only one trig ratio which links both the opposite and the hypotenuse. There's only one. So I know that sine of 20 degrees is equals to opposite over hypotenuse. That means my horizontal component will be T sine 20 degrees. For vertical component, this is my vertical component, right? And this component is adjacent to the angle. There's only one trig ratio which combines both the adjacent as well as the hypotenuse. So I can simply say cos of 20 degrees is equals to adjacent over hypotenuse. That means Ty is simply T multiplied by the cos of 20 degrees. Are you together? So instead of drawing my free body diagram like this, I can draw the one that has the components of my force. So this will be the vertical component and I'll have a horizontal component over there. So this will be Ty. I know Ty is equal to T cos of 20 degrees, and then this is T sine of 20 degrees. Are we together? Okay, to answer this question over here, they want me to find the magnitude of its tension. For me to find the tension, guys, I must use I must simply use my F net. Are you together? Firstly, the forces are at equilibrium, which simply means that my gravitational force is equal to the vertical component. Are you together? F net for the vertical dimension is equal to 0. The charge is not moving, is stationary. Are you together? Which simply means Ty minus the weight is 0, and hence Ty is equal to the weight. But Ty is just T cos of 20 degrees. And then the weight is mass multiplied by gravity. Né? Remember that you are given the mass of each ball, right? The mass of each ball, that's 100 grams, which will be 0.1 kilograms. Né? In physics, guys, we must always write our mass in kgs. So just take the 100 divided by 1000, you'll simply get 0.1. And then the gravitational acceleration is simply 9.8. That means the tension is 0.1 times 9.8 all over the cos of 20 degrees. So this will give me 0.1 times 9.8 over cos 20. Over cos 20. So this is 1.04 newtons. My tension is just equal to 1.04 newtons. Are you together? The magnitude of the tension, that's 1.04 newtons. So now they want me to calculate the distance between balls P and Q. For me to calculate the distance, guys, I must know the magnitude of the electrostatic force. But since the two balls are stationary, guys, né? Or rather, since my sphere P is stationary, it simply means that the horizontal component is equal to the electrostatic force. Are you together? So I know that Fe, the electrostatic force between the two charges, is equal to K Q1 Q2 over R squared. But I know that this electrostatic force is equal to the horizontal component of sphere P. The horizontal component is just the tension, which is 1.04 multiplied by the sine of 20 degrees. Remember that, guys, we did find that our horizontal component is T multiplied by sine theta, and our vertical component is T times cos theta. So this will be equals to 9 times 10 to the power 9. And then the magnitude of the forces is 250 nanocoulombs. 250 nanocoulombs, guys, remember, is times 10 to the negative 9. Ne? I'm looking for the distance apart. Obviously, I can cross multiply such that R squared is equals to 1.04 times sine 20 degrees is equals to 9 times 10 to the power 9, and then 250 times 10 to the negative 9, 250 times 10 to the negative 9, yeah? And hence R will be equal to 9 times 10 to the power 9 times 250 times 10 to the power negative 9, another 250 times 10 to the negative 9, all over 1.04 sine 20 degrees. Né? But remember that, guys, I had R squared. So for me to find R, I must put a square root on both sides. So therefore R is simply equals to 9 times 10 to the power 9 multiplied by 250. Let me use brackets actually. 9 times 10 to the power 9 multiplied by 250 times 10 to the power negative 9, or another 250 times 10 to the power negative 9, then 1.04 sine of 20 degrees. The distance will simplify into 3.98 times 10 to the negative 2 meters. 3.98 times 10 to the negative 2 meters, or you could have gotten 0.00398. One and the same thing. Are you together? That's how, guys, you're supposed to calculate the distance between the two. Please note that the electrostatic force between the two charges is equal to the horizontal component of charge P, and then it will be easy for you to calculate.